Welcome to Friday. I hope you guys have had a good week. I know you've been super busy, and I'm so sorry that I haven't been there to work with you, but we will fix whatever needs to be fixed on Monday. We are going to start Unit 4 today. We're going to start with the second lesson instead of the first one. It should feel a little bit more like a review for you. I would like you to have your class slides open with this video in a split screen and pause the video when I say and do the work, and then go back and check it. There is nothing to turn in and there is no homework. When you are ready, make sure you have notes out in case you want to take them. Pause the video and I'll meet you on the next slide. So beginning Unit 4, the idea we're going to be thinking about today is seeing growth in different representations. So as we move into Unit 4, we're going to find more connections and discover more ways to move from one representation of a linear equation to another. So what I'm talking about there is when we move from the pattern to the table, to the equation, to the graph, those are the different representations and formats of the linear function that we're going to be talking about. As we work through Unit 4, we're going to start to put a little more definition around things, and hopefully all of it will become much clearer. Today, we're going to focus mostly on the connections that we find going back to those patterns and writing the rule, or what we're going to call it from now on, is the equation. The learning targets that you'll have for today are: I can see growth in an equation. I know how to write the equation for a linear function. And lastly, I can find the relationship between a pattern and a linear function. We have this representations web, and you're going to see it come up quite a bit. It just shows you that as you work through the different representations of the linear function, they all interconnect to each other. The table and the pattern can create the table can create the rule can create the table can create the rule, and the graph can go back and forth between all of them. This is something I've said over and over again. I just really love this representations web because I think it puts it very clearly out there for you to understand what we're talking about. With one, you can always find the other three, and it doesn't matter which one you start with. You can represent all four of these values with just one. So we're going to be starting here today with tile pattern number 1. The questions say, what do you notice and how does it grow? So what I want you to do is I want you to pause this video, and then I want you to figure out if you can decide where the growth occurs. What does the growth look like? How is the pattern growing? All of those different things. And then after you've had some time to think about it, I will meet you on the next slide. So now we're going to actually get into this. We're going to be connecting pattern 1. So what I want you to do is, it says sketch patterns figure 0 and figure 4. How do you see the pattern growing? And use color to show the growth in the pattern. I want you to think about something we've done. These lines down here is where I want you to really write down what the number of the tiles is in each one of the patterns. This is that idea of the table. We're not going to be using a table today, but I still want you to think that way. So if you take a look at pattern 1, you can clearly see that we have 6 tiles. And then if you take a look at pattern 2, we have 6, 7, 8, 9, 10. Mrs. Brewer always has trouble adding. And then figure 3, we have 2, 4, 6, 8 in the center, 9, 10, 11, 12, 13, 14. So remember what we talked about when we were a long time ago investigating using the idea of the silent board game. I said we make the hypothesis and we check the hypothesis. So if we make the hypothesis going from figure 1 to figure 2 of +4, and then we check our hypothesis again, does +4 work? It does. So we're going to make the conclusion that our figure each time is growing by a value of +4 tiles. So we have this +4 again. So that would make figure 4 have 18 tiles. And then if we +4 to go forward, we -4 to go back, which means that figure 0 would have 2 tiles. So I want you to now pause the video and see if you can sketch figure 0 and sketch figure 4. We just answered, how do you see the pattern growing? We see it growing by +4, okay? So come back when you're done. Okay, so welcome back. So here's what I did while you were working also. I saw the gray inside as growing by a group of 2, and then the outside on the top and the bottom, each growing by 1. So figure 0 just has one stack of 1 by 2, and then figure 4 has a 2 by 5, and then 4 growing on each end to total up with 18. So I used color to show the growth in the pattern. I was able to support my growth using the hypothesis of the +4, and that is how you go ahead and do that. So let's keep in mind that in figure 0 we had 2, and then we had a growth of +4 as we move to the next slide. So what do you notice? We're going to write the rule using the growth in figure 0, and then we're going to use that rule to find figure 100. So our growth, if you remember correctly, was +4. Whoops, I don't want to use that. Let's use this one instead. Was +4. And the number of tiles in figure 0 was 2. So we're going to write the rule using the parts. All rules from now on will be in y is equal to, and we want our growth 4 to be in front of our x variable. And then the figure 0 is +2. So this is found right there, and this is found right there. And what we want to do is we want to use the rule to find out how many tiles would be in figure 100. This is our x variable. So we take our rule, y is equal to 4x plus 2. We sub in 4 times 100 plus 2. Y is equal to 400 plus 2. So y is equal to 402. There are 402 tiles in figure 100. You have done this before, so this should really feel like a review. Take a little look at it, and when you're ready, you can pause this video, and when you're ready, I'll meet you at the next slide. Again, moving forward, all of our equations are going to be in the form y is equal to. So your job is going to complete the patterns 2, 3, and 4 on the following pages, and then I will have answers for you for each one. So you should have the class slides open, and then when you're done, check your work with what I have before you move forward to the next pattern. I will meet you at the very end. Pattern 2. Go ahead and figure out the growth, figure 0, figure 4, and then do the work on the next slide. Okay, so welcome back. Very exciting news here. I actually found a different color. I found purple. So it's not really relevant to your problem, but I thought I would share. So anyway, I made my hypothesis, which was right here, that to go from figure 1 to 2, I added 4. I tested that hypothesis to go from 2 to 3, and it was +4. So I was able to make an assumption as a rule that I was growing my figure by 4 tiles every time, which means figure 14 would have 17 tiles in it. And then to go backwards from figure 1, or to figure 0, I would subtract 4, which means I have 1 tile in figure 0. I color coordinated everything. You probably might see it a little bit differently than I do, but I started with that center tile, so it would be easier to see figure 0 and then just grew by 4 around the outside and showed my growth that way. Hopefully you were able to get this. If not, take a look, take a minute, go back, think about it, and then I will meet you on the next slide. So what do you notice? We're going to write the rule again. So let's talk about our growth. Let's talk about the different parts that make up our equation. Our growth, again, was +4, and the number of tiles in figure 0 was 1. So as we write our rule, again, we are always using y is going to be equal to. Now, we always want x, and this right here is going to be our growth. This is our growth, plus or minus. And this time it's 4. You don't have to put the plus. Plus is implied. And then the next part right here, this is our figure 0. So our figure 0 is a +1. So I'm going to rewrite that whole thing down here. I'm going to not do that. I'm going to rewrite our entire thing right here. Y is equal to 4x plus 1. So now again, we want to figure out how many tiles are going to be in figure 1. And again, this is the x value. So we'll write our entire equation down. You start by writing the equation down. Please write the equation down. we are going to sub in the value of 100 for x. So y is going to equal 4 times 100 using the order of operations plus 1. Y is going to equal 400 plus 1. Y will equal 401. We have 401 tiles in figure 0 for this growth linear pattern. Let's take a look at problem 3. So here's our tiles. Again, go ahead, work on your slides, pause the video, and come back, check your work with mine. Okay, welcome back. So I want you to take a look at what I did here. I want you to see, I went back and forth a couple of times on how to represent this. The first thing I did was I counted up the number of tiles in figure 1. It was 7. Figure 2 was 11. I paused at that point and I made a hypothesis. My hypothesis was that I grew by plus 4 to go from figure 1 to figure 2. That would mean that I would grow by plus 4 to figure 3. 11 plus 4 is 15. I wrote that down. I checked my hypothesis. It was correct. So I therefore knew that I was correct and that my figure again was growing by plus 4, just like the last two. So that meant I would have to have 19 in figure 4, and then going backwards to figure 0, I would take 7 minus 4, and I would have 3 tiles in figure 0. So the next thing I did was I tried to figure out how to show the growth. Well, the growth is plus 4. If you look at figure 1, you can see the plus 4 very clearly. They are the gray tiles. And then you can see the plus 4 again in figure 2, again in figure 3, again in figure 4. And then I went to the blue highlight to go from figure 2 to 3 to 4. So I did that very clearly. That helped me go back and understand that I didn't have any of the gray tiles in figure 0, and that's how my figure 0 could be represented. I didn't necessarily need that yellow piece. All 3 of those tiles could have been blue, or excuse me, could have been red. I just showed that to you in case you were seeing it as that separate piece. So the question said, so sketch figure 0 and figure 4 done. And how do you see the pattern growing? Again, I see it growing by plus 4. I will meet you on the next slide. All right, so what did we notice? We're going to find the growth, figure 0, write the rule, and again, use the rule to figure out how many tiles would be in figure 0. Repetition, greatest way to learn. Again, our growth is plus 4, and our figure 0 had 3 tiles in it. We are going to write the rule using y is equal to, we need a value here to be in front of x. This value here is our growth, literal growth. We know that that number is 4, plus 4. And then the next part, plus or minus, these represent figure 0 number of tiles. We know that that happens to be plus 3. So our equation is going to be y is equal to 4x plus 3. Let's write that down here. We know that figure 0 is our x number. So we have y is equal to 4x plus 3. We're going to substitute in and use the order of operations to solve our problem. Plus 3. We get y is equal to 400 plus 3. And y would equal 403 tiles in figure 100. How did you do? Is it getting easier? I hope so. Let's move on. Pattern 4. All right, same process. Figure out, find a hypothesis, test the hypothesis, draw, color, label, come back when you're done. Okay, welcome back. How did you do? So as you can see, I started with figure 1. I counted up my tiles. I got 5. And then I counted up my tiles in figure 2, and I got 7. I made a hypothesis that my growth was plus 2 from figure 1 to figure 2. I tested that with figure 3, saying that if I did 7 plus 2, I'd have 9. When I counted my tiles in figure 3, I indeed had 9, which meant if I added 2, I would get 11 tiles for figure 4. And then going backwards from figure 1 to figure 0, I would need to subtract 2 to get a total of 3 for figure 0. So my growth, I sketched the patterns, my growth is plus 2 this time. Different, nice to be different. How did I use my colors? Well, what I did was I kind of started with the idea of my constant growth is plus 3. where can I see a growth of +3 consistently throughout all of my shapes? And I saw it as in this +3 coming down right here. So I saw that each one kind of like that, kind of towards the center. So then I went ahead and I drew that same idea right here. So then I said, well, where's my growth? My growth is +2, and that's where I got the 2 blue. And then I just continued through there. So that's how I developed my thought process. All right, so here we are again. What do you notice? So we're going to write the rule, and we're going to use the growth in figure 0, and then we're going to use the rule that we write to find the number of tiles in figure 0. So one more time, just practicing this. Our growth, again, was +2, and the number of tiles in figure 0 was 3. So we are going to use this. We're going to have y is equal to, and this number right here in front of x, the coefficient of x, this is our growth that we see from pattern to pattern, tile group to tile group, and that was a 2. And then the next part right here is the figure 0 tiles. We know that that was +3. So that means our rule is going to be y is equal to 2x plus 3. So we're going to use that, y is equal to 2x plus 3, understanding that figure 100 is an x representation. So we're going to write y is equal to 2, and then in parentheses 100, plus 3. We're going to use order of operations. Y is equal to 200 plus 3, multiplication first. Y is equal to 203. We have 203 tiles in figure 100. How did you do? I hope you did great. So just some reflection, just some thinking for a minute. I want you to think about a couple of things. First, what connection did you see in the equation and the number of tiles that you found in figure 0? Hopefully you see that the number of tiles in figure 0 is whatever you're adding or subtracting after the variable of x. The second thing I want you to think about is what connection in the equation did you see in the growth of the figure? Well, that is that big word that I used, the coefficient of x. So the coefficient, C-O-E-F-F-I-C-I-E-N-T. You know me and my spelling, coefficient. So if I have 4x, the coefficient is the number in front of x. It would be the 4. If I had minus 2x, the coefficient would be minus 2, because that's the value of the number in front of x. The negative goes with the 2. So hopefully we haven't worked with any negatives yet, and it's going to be a little bit before we do. But just I want you to understand what that word means. We're going to spend a lot of time there, so it's just beginning, first time through, first memory made in the brain, and we'll get back to more as we move through Unit 4. So last slide, there's no R&P for the week. Just read silently for the remainder of class, whatever that means for you. You guys have worked so hard for me this week. I'm really, really, really proud of you. I will see you on Monday. I will have your tests for you. We will clean up anything that needs to be cleaned up. Please be prepared to be called for my time on Monday. If you did not finish your test, I want you to have some time on Monday and possibly Tuesday if we need a couple of days just to get through everything. You know the end of the term is on Friday. So we will get through it. Again, I'm super proud of you for this week, and I will see you Monday.